Good morning, 5B. This is Mr. Wong. Today is Wednesday, 22nd of April. Okay, today we'll be going through the homework we have for yesterday on electric circuit symbols, and then after that you'll be doing exercise 5 in your activity book. Okay, so let's start the ball rolling. Let's go through the answers. So let's do this first. In a blank, symbols are used to represent different components of an electric circuit. So you have seen the electric circuit diagram before. So this is the answer to this part. Um, in an electric circuit diagram, right? So in an electric circuit diagram, you will have all these interesting symbols to represent the different parts of an electric circuit. Okay, we cannot always draw battery as in one rectangle and a bulb in its shape. Okay, it's very troublesome. So in science, we have symbols to represent the different parts of the electric circuit, and we join them together. We construct them in an electric circuit diagram to show the how the circuit looks like. Okay, for simple circuits is kind of straightforward, but if you look at computers, if you look at calculators, if you look at the wiring in your house, for example, if you have looked at it before, you realize it's not drawn in kind of pictorial form. It's actually in terms of diagrams, in terms of the symbols that you have learned yesterday. Okay, so actually I've gone through this yesterday as I taught the lesson yesterday. So I'm just going to go through this very quickly. So how do I show a battery? Simply two straight lines, but the longer line means something, the shorter lines also mean something. So you have to draw according to the polarity of the battery. So for example, this is the battery, the positive end is here, the negative end is here. So the longer side represents the positive end, the shorter side represents the negative end. Okay, so for example, if you have three batteries together side by side, you don't need to draw wires to connect them because as you can see, there's no wires. All you need to do is to draw three uh, three sets of batteries. Okay, so one one long, one short, and then three sets of them. So one long, one short. Draw a short one, draw a long one. This is my second battery, and then my third one. One long and one short. Right. So this is one battery. This is three batteries. One set, two set, three set. Again, the shorter end is for negative. The longer end is for positive. Okay, there's no need to join them. To join them, just put them side by side. It's taken for granted that they are placed together in a row. Okay, so I have a open circuit followed by a closed circuit. How do I draw open and sorry, I have an open switch and a closed switch. How do I draw open and closed switch? So all I need to do is for a switch, it doesn't matter it's open or closed. You start off with two circles. If it's open, it will be a diagonal line without touching the other circle. If it's a closed switch, it's just a straight line across. Okay, simple as that. Okay, so as you can see, open switch, there's a gap. Closed switch, there's no gap. Okay, so the electric current can flow through. Okay, bulb on the other hand, it is a circle followed by a cross from end to end. All right, not like a button, but the cross must be from end to end. And when we connect a bulb, usually we either do it this way, either from left to right, or we can actually connect a bulb from the top to the bottom. Okay, we try not to do a right angle connection. Okay, we usually will mark it as correct. We just do the left to right or up to down. We don't go in a right angle direction. And of course, a wire is very straightforward. A wire is just a straight line. Okay, it can be a horizontal line. If you're drawing horizontally, it can also be a vertical line. Okay, but it must be a straight line. Okay, so this is for wires. So these are the parts that you need to know how to draw, and we'll be using all this to draw our circuit later. All right, so next page. It is easier to draw electric circuit using symbols because it's much simpler, as you can see from the picture. It's much easier to draw using symbols rather than to draw the actual picture. Okay, so if you want to draw electric circuit, being a professional electrician, for example, it's definitely easier for you to draw the circuit itself using the diagrams, using the symbol, sorry, rather than to draw the actual picture, because it's gonna be very messy because the wire is gonna uh, go curvy and everything. So it's definitely easier to use symbols to draw a circuit diagram. Alright, so let's go to the next part. Okay, now we'll put our what we learned into practice. We're gonna draw all the circuits diagram for all this and see how we're going to do it. Okay, so same thing as I said, start off with putting the parts into the diagram first. So let me draw a bulb followed by the open switch followed by the battery. So I have a bulb over here. Okay, I have a bulb over here. I have an open switch and I have a battery, and I know the positive end is here, the negative end is here. Okay, so once I have the parts ready, now I use my wires to connect them together. So I'm just going to follow exactly what I see. A wire here followed by a wire here, make sure they touch, followed by a wire here. Make sure you use your ruler to draw. It must be straight, cannot be slanted, cannot be curvy. Okay, and then after that a wire here from the positive end out, and then after that a wire to the bulb. Okay, as I said before, try to join the bulb from left to right or up to down. Don't join at right angles. And then after that, from the bulb we go back to the switch, which is an open switch. Yep, so this is exactly this diagram itself. So I have the bulb, I have the open switch, I have the battery, join them together using wires. Okay, so now let's look at the other one. You realize the first and the second are the same, just that the first one the switch is open, the second one the switch is closed. Okay, so actually they are the same thing, so I'm just going to only change the switch. So what I need to do, again I'll draw a bulb over here. Go on. Okay, I'm back. So okay, so let's draw the bulb first. Okay, the bulb is here. Okay, go and draw the switch. Now the switch is closed, so it's two circles and a line joining the two circles, and then the battery positive end followed by the negative end. Gonna use a wire to connect them all. Okay, so make sure you use a ruler to connect the parts together. Cannot be a slanted line, it must be a straight line. Okay, to the bulb. Okay, make sure your wires don't go through the bulb. You must touch the circle, the outer rim, and then from the other side out, and then join to the closed switch, and make sure they touch the parts. Okay, all right. Okay, just extend this a bit. All right. Okay, so something like that. So this closed circuit is exactly the same as this. So these are the two simple ones. Okay, these two are difficult, so we spend some time on it. Okay, you realize there are two batteries and the plus is over here. So I'm gonna draw two batteries first. Okay, I think batteries either use a pen, use a ruler, or you can just draw two straight lines. I think it's still okay. So I have two batteries here. Okay, let's draw properly. Okay, I have negative N, positive N, negative N, positive N. Two batteries, two batteries. I have three bulbs over here, so I will draw three bulbs, one bulb, two bulb, three bulbs. Okay, so first you always draw the parts down first. Two batteries, three bulbs, three bulbs. After that, all you need to do, connect the bulbs together or connect everything together using wires. So here to here, one wire, draw downwards to the bulbs, and then after that, connect the bulbs together and make sure the lines touch the bulbs. Make sure there's no gap. Okay, try to join them from end to end, left to right or right to left. Okay, and then join them back to the batteries. You realize in this circuit there's no switch. So as I said before, switch is just to control the flow of the electric current. You can don't use a switch, it's fine. But usually for safety reasons, usually we use a switch to control whether the circuit is turned on or turned off. Okay, so this is what you need to do. So once again, after you're done, please check two batteries, negative, positive, three bulbs, join them together. All right. Okay, so for the last one, also the same thing. Start off with the batteries. You have two batteries, same thing, negative first, then positive. So let's draw it down first. Negative, positive, negative, positive. So there's the two batteries. But now you realize you have three bulbs, not arranged in a different way. So you really have to look at how they are arranged and then put together. So I have a bulb over here. I have a bulb over here. I'm going to draw outside the box. It doesn't matter. And then I have a bulb over here. So there are three bulbs in total. So first, always draw the parts. So two battery, three bulbs. Okay. Now let's join the parts together. You realize that it is from. Okay, let me highlight for you to see. It is from. Okay, use another color. You realize it is from the battery to one bulb, and then to another bulb, and then back again. So we're gonna follow this layout. Draw out from the positive end. Okay, I'm gonna draw one straight line down. Like this. Okay, you realize from the positive end, it goes to the first bulb, which is something like that. And then from the first bulb, it goes to the second bulb, which is something like this. And then it goes to the third bulb, which is something like this. Okay, so always use a ruler, make sure it's straight. Then after that, same thing, do it on the other side. From the negative end, comes down all the way here. Okay, connect to the bulb. Connect to the bulb. And then after that, also do the same for the last bulb. And this is how you draw your electric circuit diagram. It can get more complicated, but I think this is the one of the more difficult ones here that you should have. You need to know how to draw. Okay, so once again, after you're done, check two batteries, positive to negative, three bulbs over here, and the wires connecting all of them. Okay, so all you need to do for every circuit diagram you see, draw the parts down first, and after that look at how the wires are arranged and then arrange accordingly. Okay, it's actually quite simple to draw electric circuit diagrams. Okay, now we go to last page, page 20. Okay, so this is a like concept map or summary chart. So let's fill in the words that we know. Okay, I have electric circuit. Let's start from here. Electric circuit is a system. Okay, electric circuit is actually system because made of different parts. Okay, so electric circuit is let me see if it's correct. Yeah, correct. Okay, electric circuit is actually a system, okay, which is made up of different parts. And what are these parts called? Let's start from the simplest, the battery. So it is a system because it's made up of different parts. Batteries, you have your wires, you have your bulb, and then you have your switch. Okay, but you definitely need these three, the first three, to work. Okay, without the first three, your circuit cannot work. So I'm just going to do something like this. Okay, so these are the must have. Okay, so every circuit must have battery, bulb, and wire. These are the must-haves. Sometimes you don't need a switch, but sometimes in a circuit you have multiple switches to control the different bulbs in the circuit. Okay, so but you need definitely a battery, which is the energy source, the wire that connects the different parts together, and the bulb to give off the light. Okay, so so all these parts can be represented by symbols, which we learned yesterday and today. Okay, can be represented by symbols which can be used to draw circuit diagram or electric circuit diagram. Okay, so you are using symbols to draw electric circuit diagram. Right. Okay, go to the next part. Electric circuit is a closed circuit when there is no gap. Okay, so if we're talking about closed circuit, there is no gap. Okay, closed circuit, there is no gap, and therefore electric current can flow through the electric circuit. Okay, so if there's no gap, electric current can flow. Okay, so on the other hand, opposite of closed circuit is an open circuit. Open circuit means that there is one or more gaps in the circuit, and therefore the electric current cannot flow. Okay, so closed circuit, there's no gap, electric current can flow. Open circuit, there's a gap, electric current cannot flow. Oh, you don't have the word cannot. Okay, let's put in the word cannot for them. Cannot. Okay, let's put in blue so you'll see the addition. Okay, so it's around here. Okay, move a bit lower. Alright, okay, so closed circuit, there's gap, electric current flows. Open circuit, there are gap. Closed circuit, no gap, electric current can flow. Open circuit, there's gaps or one gap, electric current cannot flow. Okay, so the last one, conductor, insulator, electric conductor, insulator. So electric conductor are basically your metals, for example your copper. Okay, your iron, let's name some material here, and your gold, for example. Okay, which allows electric current to flow through. Okay, so on the other hand, okay, let's just highlight electrical insulator. Electrical insulators are things like your non-metal, for example your glass, your rubber, and your plastic. And glass, rubber, plastic, they are called electrical insulators because they do not allow, they don't allow, or they do not allow electric current to flow through. Okay, so this is the answers for page 17 to page 20. Make sure you do your corrections as you watch the video. And then today the homework will be exercise 5, page I think 38 and 39 if I'm not wrong, from the activity book. Okay, see you tomorrow.